Welcome back. In this video, we're going to start talking about kinematics in two dimensions. But before we even do that, I just want to spend 15 seconds. I probably should have done this in the very beginning, but just my tips on what I'm going to try to do throughout these videos and how you should approach studying for physics. And then we'll get right to it. So, first thing is, my goal is to give you the intuition behind all of these problems. But at the same time, I realize that when you take a test, you need to know how to do those really difficult problems. So really, I'm all about giving you intuition plus really kind of strange and difficult practice problems with tricks, right? So I'm going to be idealistic and intuitive. At the same time, we're going to be practical and make sure we get those difficult questions. So that's kind of where I'm coming from. And the second thing I wanted to just say is I would actually recommend watching these videos before you even go to class. So that way when you go to class, you're going to kind of know what's going on. And this will give you a really good foundations. When you go to class, you're just there to like pick up everything. Okay, that's my 2 cents. From now on, we're no more philosophy. We're only doing physics. So now we're going to start describing motion in 2 dimensions. So when I said that, how do you describe motion? There's only 6 things to look for, right? So there's what? There's acceleration, there's v initial, there's v final, there's your initial position, your final position, and your time. Okay, I said there's always 6 things. That's all they can ask you is 6 things, so just write these 6 things down. So I kind of lied about this. There's actually 12 things, right? But let me before you start hating on me, what are those 12 things? So before we were saying there's only 6 things to describe motion because everything we were looking at was going in one direction, right? So the first problem we looked at, there was a car going in the x direction. Then we had a stone that fell all in the y direction. Then we threw a stone upwards, again, in the y direction. So when you are doing in just one direction, right? So this is your x and this is your y. When your object is moving in just one direction, or in one plane, right, in the x or in the y, that's kinematics in 1D. But what if my object is falling like this, right? What if it's going down and to the right? So that's in 2 dimensions. So 2 dimensions. So what happens when that happens? Well, now you have, instead of 6 ways of describing this motion, you actually have 12 ways. What are those 12 ways? It's the same 6, but you now do it for x and y separately. So I would say, what is the acceleration in the x direction? What is the v initial in the x, right? So v, let me clean this up. V initial, comma, x. What is the final velocity in the x? What is the initial x position? What is the final x position? And what is time? So I would want to look for all of these. Equals. And then in the y side, I would want to do the exact same, but for the y component. So what is the acceleration in the y? What is the v initial in the y? What is the v final in the y? What is y initial, your initial y position? What is your final y position? And then what is time? Okay? So when I say, it's still the same fundamental 6 things you're looking for, but now you're going to do it for both x and y. But I swear to God, I'm never going to lie again. It's not like in the next video I'm going to say, by the way, there's 18 things. No, it's always, when you're doing 2-dimensional motion problems, it's just these 12 things. So what are we going to do for every single kinematics problem that's in 2 dimensions? We're going to write down these 12 things, and we're going to put question marks next to things we don't know, and we're going to put in numbers next to things we know, and again, we're going to do our kinematics equations for these. So the strategy is, again, write all these down, all your variables. So write them down, and then when we use our kinematics equations, we're going to do them separately for x and y. So when I say v final equals v initial plus at, you can't just say this anymore. You have to specify, am I talking about x or am I talking about y? So you have to say v final comma x equals v initial comma x plus ax times time. Okay? So you have to do them separately. So I'm going to put a giant, no, you know what? Let's change the color. I'm putting a wall between x and y because this wall is a metaphor. You are never going to mix these two together, okay? So you're never going to do this. V final, comma, x equals V initial, comma, y plus axt. You can never have x and y in the same equation. No, 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 no. That's bad, and that's a very common mistake people do. So always treat them separately. So everything we learned in the last videos is the principle is the same. Find the 6 variables and then treat it separately. Just now you just have to do double the work. You just have x and you have y, but it's all separate. Same exact equations, v final equals v initial plus at, but then do comma x, comma x, comma x, or comma y, comma y, comma y, depending on what you need to find. Okay? So, and people always wonder, how is this possible? Can you just do that? Like you can just look at x and y separately? Yes, you can, right? It's like when we were describing, remember when we described motion and I said you can break it into separate parts, a part 1 and a part 2? You can also look at the x component and the y component completely separately. There's ways to prove that, but interest of time, I think we get it, right? There's a big wall, and you just do them separately, and you can look at them separately, and things work out great. Okay, so let's do a problem. So let's get, oh, and actually before we do that, you might wonder, what about time, right? Is time an x quantity or is it a y quantity? And again, time is just time. So really, you don't have to write time twice because time is just neither x nor y. It's time. But I just write it. So let's say it took us 10 seconds for the object to go from here all the way down, right, in x and y. Then the x time is 10 on the x and time is 10 on the right. It might seem a little redundant, like why write it twice, but it also just keeps it consistent, right? I told you always write the 6 things, just do them separately for x and y. So you will need time for y and time for x separately. So you might as well just write it twice like that. Okay, let's do a problem. So let's say, this is a classic problem right here. So let's say you have your airplane. Here's my airplane. And the airplane is going 150 meters per second to the right, so therefore it's positive, okay? And let's say there is, here's the ground. So I'm going to draw some grass, so you see that's the ground, and your plane is 1,000 meters above the ground, 1,000 meters, okay? And last but not least, you have a package that is attached to the plane. And as this plane is flying, it's going to eventually let go of this package. So it's going to fly, and then it's going to just let go. And so what's going to happen? What's going to happen is, well, your plane is flying, and if your package is with it, right, the package is also going at 150 meters per second. So you're giving it an initial velocity, right, of 150 meters per second, and then it's going to kind of fall down like that, okay? So hopefully that makes a little sense. But the plane and package are traveling together, and then after a while you release the package, and it's just going to kind of, because you have this initial 150 meters per second velocity, it's not going to just fall straight down, right? That wouldn't even make intuitive sense. It's going to like curve like this, like that. Cool. So the question is asking you, how long is it going to take for the package to reach the ground? So what's the time? Where is the package going to fall? And how fast will it hit the ground? So how fast it's going to hit the ground. Okay, so where do I begin? The classic question I've been asked, where do I begin? Well, you always begin with the same set of rules. You're going to write out your 6 things, acceleration, all that, but now you're going to do them separately for x and y. So first of all, you have to recognize that this is motion in 2 dimensions, right? Your object is moving in both the x plane, because it's going this way, and it's also going down in the y planes. So you have to do it separately. So we have to find all, so where do I begin? Write out the 12 variables, ax, v initial in the x, v final, comma x, x initial, x final, time. acceleration in y, v initial, comma, y, v final, comma, y. And I know that's getting annoying, but I'm going to be annoying about this. So y initial, y final, and then time. So look, everything is y, everything is x, and we're going to put our wall. Obviously, you don't need to draw this wall every time. I'm just doing it for dramatic effect. All right, so let's figure out what we know and what we don't know, and then we can do some kinematics. So what is your acceleration in the x direction? Okay, well, we know the plane is traveling 150 meters per second to the right. So actually, let's do that one first. If you're going 150 meters per second entirely in the x direction, right? It's going all the way, look, this is x, so it's going all the way to the right. So you know your v initial in the x is 150 meters, okay? Meters per second. Which means in the y direction, you don't have any initial velocity. You have 0, because the only way you would have an initial velocity in the y direction is if your plane was going, either straight up or it was going at some angle. And if it was going at some angle, then you could break it down into x and y. We'll get more into this later, how to break it down, but just intuitively, right now the velocity is all going to the right, so therefore it is positive 150, and there's nothing going on in the y. What about acceleration? Well, you're in the x direction, right? Well, let's do y first. So we know acceleration in the y, right? Gravity always accelerates objects down at a rate of negative 9.8. So the minute this package is released, gravity is going to be accelerating it down. And since down means y direction, we know it's going to be in this box, acceleration y is negative 9.8 meters per second squared, right? Gravity is not pushing to the right or to the left, so therefore your acceleration in the x direction is 0, because gravity is not pushing left or right. It always pushes down, which is a y direction. So sometimes people ask me, how can you have acceleration in the x direction? Well, if this plane was releasing some fuel that caused it to actually accelerate in the x direction, so they would have to tell you this, right? Or they would have to ask you to figure it out. Like, they would have to say, oh, your plane is accelerating, let's say 5 meters per second to the right or to the left. They would have to tell you that. So they don't tell it to you, you assume it is 0. And notice here, gravity is accelerating down at negative 9.8. All right. What is and you know what, let me clarify one thing before we even move on, right? So let me just clarify something really quickly. If you have, let's say this, maybe I should have done this in an earlier video, but I'm going to do it now. Let's say your plane was going like this, 150 meters per second at a 30-degree angle, right? Planes can do that. They can fly up like this, okay? Then what is this? What's going on here? Is this 150 meters in the x or in the y? Well, it's neither, right? It's in between. So this is called a two-dimensional vector. That's a fancy way of saying it. The way I think about it is it's in between x and y. So anytime you have something that is two-dimensional, right? It's not entirely in x or entirely in y, but it's sort of in between. Anytime you have that, you want to break it down into its x component and its y component, okay? So anytime you have something that is two-dimensional, this is another theme of physics. What theme are we on? Are we on number 3? I think so. Break it down into x and y, because two-dimensional things are very useless for us, right? Look, everything is either in x or in y. It's not like I have a separate category that says, hi, what's 2D? No, we don't do that. Everything is x or y. So if you see something that's 2D, 2D meaning it's in between, it's not one-dimensional, it's in between x and y, break it down into its x component and y component. And you can do that. People always say, oh, how do I do that? You can break things into its x component and y component. So how would I do that? How would I break down 150 into its x and y component? Well, you know this angle here is 30. right? And you have kind of a triangle, a right triangle. So I can say that the cosine of 30 degrees is what? What is the cosine of this angle? It's adjacent, which is the x component, the x side. So I can say, we're talking about velocity, initial velocity, so I can say that's vi comma x, but really it's just this side, divided by your hypotenuse, which is 150. So v initial comma x is 150 cosine 30. And what about the y side? So here's y. Well, the sine of 30, remember sine is opposite over hypotenuse. So the sine is the y component, which since we're talking about velocities, is vi comma y divided by your hypotenuse, which is 150. So again, vi y equals 150 sine of 30. So that is when you would, this is a case when you're given a velocity, your initial velocity, and you get both an x component and a y component. So hopefully now this makes more sense why in this situation this is only in the x direction, because it's only going in the x, right? You can't break this into its x and y because it's already in x. So that's why 150 goes entirely in this bucket. But if you were given this situation, then you would say you would put this in your x column and this in your y column. Okay. I hope this makes now a little bit more sense. We're going to do a lot more problems if it does not, but this is a good start. Okay, and let me erase all this mumbo jumbo. So let that sink in, or maybe even fast forward the video. I'm wasting your time. Sorry about that. But we are almost done with erasing. Okay, back to it. So I'm about to teach you another cool trick. What is the final velocity in the x direction, right? What does that mean? That means when this object is falling, right before it hits the ground, okay, it's going to have a final velocity, right? Right before it hits the ground. And actually, it's going to, let me get rid of this as well. How is it going to hit the ground? If you think about it, it's not going to hit the ground directly straight down anymore, right? It's not like you're just dropping this object. It's going to hit it, it's going to go, 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 it's going to curve, and then it's going to hit it like at an angle, like this. Right? It's going to hit it at this sort of two-dimensional. Notice, this is also two-dimensional. It's not going to just hit it straight down or to the right or to the left or up, right? It's going to hit it at an angle. So this is really your final velocity. This is your final velocity. And anytime you see something 2D, you break it into x and y. So again, I can break this into x and y. I can say this is v final, comma, x, and v final, comma, y. And how do you do that so quickly? Like, people are like, how do you do that so quickly, right? Basically, you're making a right triangle. When you break something into x and y, you just draw x, and then so you start with x, you keep going, and then until you can make your right triangle, right? That's your right angle. So that's how you do it. You just keep going, and then bam, I hit my right triangle, and I can go up like that. So that's how we do it. So if you do have a final velocity at this angle, then you definitely have an x component and you have a y component. So what are those x and y components? Well, we clearly don't know, right? They don't tell you any information, but I'm going to teach you a little trick. If you are starting with a v initial of 150 in the x direction, and you're changing it 0, right? Acceleration means your change in velocity. So if I start at 150 and I change at 0, what's my final velocity? It is still 150. Look at that cool trick, right? You're starting, and again, you just treat x and y separately. So only look at x. I'm starting at 150 in the x direction. I'm changing it 0. So this is why it's nice to have intuition behind acceleration and all these concepts, frankly. But you're starting at 150, you're changing it 0 meters per second, right? So if you start at 150, you change it 0, you end at 150. So notice, you can just add that in. And most people will not just do that, add that in. They're going to struggle because it's not given anywhere. So this is why when I write my 6 variables, acceleration, v initial, v final, blah, 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 I always write it in this order. I always start with acceleration, and then I do this one next, and then I do this. Why do I do that? Because if I write acceleration and v initial first, then by the time I get to v final, I can quickly see, oh, if my acceleration is 0 and I have a number here, then this becomes that number, right? I can just copy it really quickly. Versus if I wrote like, you know, time and then v final and then acceleration, I might not see that as easily. But if I write it like this, I'm going to see it very, very quickly. I'm going to see 0, 150, so therefore it's 150. Again, this is not taught in any textbook. This is just a trick I like. After after struggling a while, I noticed this pattern, so I started writing it this way. So hopefully you can use this trick, and it'll help you. So let's go on the right side. Here, can we use that same trick? Well, let's try. I'm starting at 0, and every second I'm changing negative 9.8, right? So what's my v final? So on this side, you can't really do that because you're starting at 0. You know after a second you'll be negative 9.8, then negative 19.6 after 2 seconds, but you don't know how long you're in the air for. So here you have to just say question mark. So this trick only works really when your acceleration is 0. So let's write it out. I don't know, is this a theme? Well, it's really I don't even know. We'll write trick. So trick is if your acceleration is 0 and your v initial equals, let's say, x, then therefore your v final equals that same number, x, okay? And write it in this order so you'll see it. Okay, let's keep going. What is your initial x position? We can just say it is, oh, do I want to open Java? No, thank you. Okay, what is my initial x position? We can just say 0, right? It doesn't say it explicitly in the problem, but you can just say, okay, I'm starting here, I'm ending here, so this is 0. You basically always start at x initial is 0, unless they tell you directly you're starting at x initial is 5 or 10 or something. Okay, what is your y initial? You start 1,000 meters above the ground. Your x final, again, we don't know. We don't know how much that is. What's your y final? Well, you reach the ground. You hit rock bottom, 0. And what's the time? We don't know. We don't know. All right, so we finally have all the variables we know and what we don't know. So what's the first thing we need to do? First thing we need to do is figure out time. So how are we going to figure out time? Well, you can figure out time from either side, right? Because if it said tell me v final comma y, then you know, okay, I need to go directly to v final comma y. But this is saying tell me time. So time is one of the greatest variables because you can go to either side and get it. At the same time, that causes sometimes a little bit more confusion because you don't know which one to do. So how do you know which one to do? Pick the side which has more stuff, right? Because if you have more question marks, then that's not going to help a lot. So you can really do either side, and you just have to see which one works. So on this side, you have a lot of stuff, right? You only have one question mark, but a lot of it is like you have a lot of zeros, right? So if you plug in 0 into your equations, a lot of things will cancel out. So it doesn't seem too helpful. Whereas on this side, you have a lot of you have 1, you have, you know this. So let's try to use the y side. And this will, let's see if that works. I'm going to erase this trick. All right. So let's change colors to decrease boredom. So let's figure out the time using the y side. So how can I do that? How do I get time? I can do v final equals v initial plus at, but I don't know v final. So the only other equation with time is delta y is equal to vi y t plus 1/2 a y y t. That's not nice. Let's rewrite this clearly. Acceleration in the y t squared. So notice everything is y. Delta y, vi y, acceleration y. You always keep it separate. Okay? So what is the change in y? You're going from final minus initial, 0 minus 1,000. So you're going down 1,000 meters. Makes sense, right? You're going down 1,000 meters. Okay. Let's get rid of that. So there you go. What's v initial? 0. So that's nice. We don't even have to worry about that. Plus 1/2 negative 9.8 t squared. So cool. You have everything. You solve for time. And give me a second. I will actually just tell you what that is. So what is time? Time is, I believe it is 14.3 seconds. Cool. Okay, so now this is no longer a question mark. This is 14.3. 14.3, and same on this side, 14.3. Because time is really, it's not really exclusive to x or y, but you can use it in both. That's why you write it twice. Okay, so we got time. Where are we landing? Right? So what does where mean? In English, it means where, but what does that mean in physics, right? That's what I meant to add. Where is actually asking, if you're asking where you're landing, you're really asking what is your y final, your final y position, and your final x position. Where am I landing? Well, I can tell you I'm at this location. So I need the y final position and the x final position. You know the y final position is 0, right? You're at the bottom. That's pretty obvious. So what's basically the problem is asking, what is your x final? Okay, so let's erase this. And let's erase all this up here. All right. Alrighty, erasing our material. That's like a nice little mental break. When I erase, just take a nice little mental break. All right, back to the problem. So what is x final? So how do I get x final? Right? This is pretty obvious. You go to x. You don't go to y when you need something x related. So you just go straight to x. So what is, oh, I'm sorry. Why did I write x final equals 0? This should be x final equals question mark. I was getting confused with y. So you start here. You start at 0 of x initial, but you don't know how far you've traveled in the x position. So sorry about that if that caused confusion. But that is x final, we don't know. All right, so how do I figure out x? Again, there's only two equations. Let's use this one. Delta x is vi x t plus 1/2 a x t squared. Everything is in x. Delta x, vi x, a x, right? And then time is just time. So everything's in x. Let's do it. So what's delta x? You're going from final, which you don't know, minus initial, which is 0. So that's just x final minus 0, which is x final. V initial in the x is 150. Your time we just figured out. How convenient. So you'll notice physics problems often build on each other, right? You'll figure out the first variable, and then you can use that time in the second part. So yeah, just good thing to note as a test-taking strategy. So plus 1/2. And then acceleration is just 0 in the x. So this is all just 0. So what's 150 times 100 times 14.3? That is, I believe, 2145 meters. Right? That makes sense? Yeah, because 150 times 10. Yeah, okay, so that's good. That's your x final. Cool. Done. Next, last thing is how fast do you hit the ground? Okay, so basically what that is code word, again, translate English to physics. That's asking what is your v final, right? What's your final velocity? How fast are you hitting the ground? So take a little mental break while I erase all this. Alrighty. Okay. And let's change colors for get some excitement. So what is v final? Again, so since we're dealing in 2-dimension, what this is really asking is actually not what is v final, but what is, well, sorry, it is asking what is v final, okay? That's what the problem is asking. How fast does it hit the ground means what is v final. What we're going to tell is, we're going to do is we're going to figure out v final x and v final y separately, right? And then once we do that, we'll actually combine them together to get a 2-dimensional quantity. So we're going to do x and y separately, and then we will build it back to get your v final. So remember when I said anytime you see something 2-dimensional, break it down into x and y? I strongly emphasize that. But if the problem is asking you for a two-dimensional vector, then you have to take x and y and then build it back up to two-dimensional. If that's confusing, let's just do it and you'll see what I mean. Okay, so this theme is still true, is what my point is. But let's just do it, so we'll see it what I mean. Okay, so what is v final? Well, we know v final in the x is 150, right? We used our little trick where if the acceleration is 0, then you're not changing, so you're at 150. So that's done. That was, see, nice trick. You save some time. Okay, so what's v final in the y? V final in the y is, let's just do v initial in the y plus a y t, right? Nice and simple. So that's 0 plus acceleration is negative 9.8 times 14.3. And let me figure out what that is. That is going to be, all right, calculator, why are you freezing? Give me a second. 1 second. Well, can we just approximate it? My calculator is malfunctioning on me. This is 10, right? Basically, this is 10. So this is basically negative 143 meters per second. Okay. And again, does this make sense that we're getting a negative number? Negative means down. Is the y component going down for the final velocity? Yes, it is. So that makes sense. And is the x component going to the right? It is. So that makes sense that we got positive. So always, whenever you generate a number in physics, check, does it make sense, positive or negative? Okay, so now what do I mean by, taking x and y and making it 2D? Well, very simple, right? So your x component is 150, right? This part here. Your y component is negative 143. Whoops, negative 143. So what is v final? V final is a two-dimensional again, meaning it's not entirely an x or y, and it's going like so, right? So to get this, you just do the same, you can just do Pythagorean theorem. You can just say 150, so this is v final as a two-dimensional vector. It's not x or y. This is v final x, v final y, and to get v final, you just say 150 squared plus negative 143 squared equals v final squared. So Pythagorean theorem, right? A squared plus b squared equals c squared. All right, and that should get you, let's see if my calculator decides to cooperate. Give me 1 second. And let's see. How do I? There we go. Okay, it's working. Let's see. 150 times 150 plus 143 squared, and then you take the square root. Oh my god, why is my calculator not working? Well, it is some number, okay? You can figure this out, what that number is. Okay, now, it's some number. So you might think you're done at this point, right? You have a final velocity and you have a number. But, what is the definition of velocity, right? Velocity is speed with direction. So every time we have been giving direction. It's just weird because we keep saying negative or positive, so we don't realize it, but that's why I want to keep emphasizing it. So here we said the direction was down, right? Negative 143. In the x direction, we said it was to the right by saying positive 150. But what is this? Is this going to be positive or negative? Well, this is neither. It is a two-dimensional, right? It's going down. Two-dimensional. It's neither up or down, left or right. It's somewhere in the middle. So you actually have to not only give me the number, you have to give me the angle with it, right? Because you always have to give speed with direction. So how do I give this angle? again, you do you use sine, cosine, all those tricks. So you can actually, let's use tangent, right? So we can say that the tangent of this angle, theta, is negative 143. So tangent is opposite over adjacent. Negative 143 divided by 150. And that'll give you your theta. So that'll give you, so your, how fast are you hitting the ground? What's your final velocity is going to be whatever that number is plus whatever this angle is. So you have to say whatever that number is, meters per second at this angle. And sorry, my calculator's malfunctioning, but when you figure this out, that'll be your answer. So you have to give both the number and the angle, because that's your speed plus direction. All right, that is all.